Hi guys, and welcome to the 9.3 section on solving quadratic equations. As we're moving throughout the PowerPoint here, you should notice a couple things that I'll point out as far as when you should be taking notes and when you should be solving on the whiteboards. So from here on out, the standard that we're working on today is the write and solve equations in one variable and use them to solve problems using quadratic functions. We're going to do a quick review. And if you notice up here in the upper corner, there's no notebook icon that you'll see later, which means that this is just a review. If you know it, that's great. If you're not certain about it, you might want to take a minute and write it in your notebook. So when we're looking at a quadratic equation, it creates not a straight line, but the shape that we call a parabola. And when the parabola crosses the different axes, we get a number of specific features. So for example, where the parabola crosses the x-axis, we get two x-intercepts. Then wherever it crosses that y-axis is where we get a y-intercept. Then the vertex is either the lowest or the highest point, or what some people consider the turning point of the parabola. And then wherever that imaginary line, if you will, through that vertex that is perpendicular, is the line of symmetry. Some people like to think of that as if they folded that parabola in half. Those lines of symmetry would match up perfectly. So this is the basics of a quadratic equation and a parabola graph of that equation. So new to us today is that whenever we have a quadratic equation which graphs into a parabola, we can always write it in our standard form. And our standard form always looks like something times x squared plus something times x plus c equals 0. And setting that equal to 0 will become an important part as we move forward through working with quadratic formulas. So again, standard form, something times x squared plus something else times x plus c equals 0. Now, we can solve quadratic equations when we graph them. So the easiest way to solve them are by finding what is called the x-intercepts. In math, we refer to those with quadratics as either the roots of the equation or the zeros of the function. Now, the zeros of the function come from the idea that this is where our y value is equal to 0 because there's no up or down movement on that y-axis. So if we're looking at a graph, simple and straightforward, that we would be able to look at the graph, find our x-axis, and then identify the two places where the parabola crosses the x-axis. For this specific equation, we can see that it's at -5 and at -1. So we call -1 and -5 the roots of the equation or the zeros of the function. Let's take a minute and look at a few other parabolas and see about solving them by using their graph. So we're going to look at a few examples of our parabolas or our quadratic functions here. We can see this function right here is another parabola. We can tell by the shape, so we know that it fits that standard form. You can actually see up here the equation of it. If I can adjust my camera. And it tells us this one is actually y equals x squared minus 2x minus 3, which gives you a nice way of seeing that standard form. Something times x squared minus something else times x minus c. So when we look at this parabola, to be able to tell our zeros for the function, we can see right here that this crosses that x-axis at -1 and at 3. So the zeros or the roots for this equation would be -1 and 3. Now sometimes our parabolas are inverted, and so they might produce a graph that looks something like this. Again, we can see that this equation has zeros or roots, except these happen to fall at 6 and 8. So the solutions for this parabola are at 6 and 8. Next on the list, you can see again another nice quadratic equation there. We've got a nice graph of the equation right there. We can see again it's crossing the x-axis at the points -4 and 2. So the solutions for this one we can find really easily at -4 and 2. Sometimes, though, when we're working with our parabolas, they don't always necessarily have one solution. So this, or excuse me, they don't always have two solutions. Sometimes they only have one. Here's a pretty standard parabola that we can see, but there's only one point where this parabola is crossing the x-axis. And so the intercept for this one, or the root for this one, is just there at 0. You can see that parabola sitting neatly right there in the origin. So you might ask yourself, okay, well, what else could go wrong? Well, sometimes our parabolas don't cross the y-axis, or excuse me, the x-axis at all. So you can see this one is translated up to 4 for its vertex, so it actually has no roots or no solutions at all. And that means that this one doesn't cross that x-axis. If we were solving for the roots or solving for the zeros, there would be none. Next, on the other side, you might say to yourself, okay, Dawn, why do we need any way to solve other than what you've shown us since they're all so easy? Sometimes when we come across a graph, we can tell that the intercepts, the zeros, the roots, are not easy to read. So because of that, we need a more efficient and more precise way of solving those equations, which we're going to learn how to do next.